My name's Kirby Atwater. I'm located in the Chicago area and one of the product marketing engineers for the MEMS and sensors technologies in North America. What I'm going to talk about a little bit is some important points about ST's MEMS sensors as it applies to wearable technologies. So when you consider the IoT wearable space, ST is very well positioned to support a wide range of wearable technologies. We have an extensive portfolio, as well as our Bluetooth, low energy, and sub-gigahertz wireless technologies. Together can offer a complete solution for sensing and communication portions of the wireless IoT applications and wearable applications. Our MEMS motion sensors are capable of sensing simple motions, like a wake from sleep scenario, but also capable of sensing and making decisions based on multiple and complex movements or a series of movements and gestures. Our environmental sensors are available to sense temperature, pressure, for maybe elevation sensing, and then also relative humidity. And all these capabilities are exceptional foundation for the development of some of the newer tracking bands that have been requested by some governments to help with contact tracing for COVID-19. Having a Bluetooth low energy radio and a very low power accelerometer create a very efficient solution able to be powered by like a coin cell or other small power source. To evaluate and develop with our sensors and wireless components, ST has developed a few different hardware tools and accompanying software tools to aid in the evaluation, both light and full featured development processes that may be required by your engineering team. So first, we're going to take a look at the SensorTile.box as a great example. The SensorTile.box as shown here is the little blue box with many different sensors, both motion and environmental based, as well as Bluetooth low energy communication that works with our Android or iOS implementation of the STBLE sensor app for your smartphone or tablet. Both are available on the respective app stores on Google Play if you search for STBLE sensor on either one of the app stores. Let's take a further look at the SensorTile.box and some of its internal components. So here we see the top of the PC board on the left. The SensorTile.box is powered by an STM32L4 microcontroller. Includes a grouping of environmental sensors, as well as a Bluetooth Low Energy 5 module for communicating to the STBLE sensor app on your smartphone or tablet. And then also a grouping of motion sensors in the upper left-hand corner. Finally, a micro USB port for direct connection for additional communications, and also for advanced development capabilities that we'll talk about in a little bit. On the right side, you see the reverse side of the PC board, the 500 milliamp lithium polymer battery. Under that battery, there's a micro SD flash card slot with capabilities of supporting up to 8 gigabytes of SD flash, which you can then use to store sample data for later processing after acquisition. Finally, there's an ST-Link V3 for direct debug connection to the STM32L4. So let's take a little further look at the sensors on board. If we take a look at the motion sensors first, we have the LSM6DSOX. It's a 6-axis accelerometer and gyro combo, what we refer to as an IMU, or inertial measurement unit. This particular device has built-in finite state machine and machine learning core capabilities. A little later on, an in-depth discussion on this functionality will be presented by one of my colleagues. Additionally, there's two different 3-axis accelerometers, the LIS3DH, an ultra-low noise 2.5G precision inclinometer, and the LIS2DW12 ultra-low power accelerometer. And finally, we have a 3-axis magnetometer, the LIS2MDL. For the environmental sensors in the middle, we have the LPS22HH, our absolute atmospheric pressure sensor, the STTS751 digital temperature sensor, and the HTS221 relative humidity sensor, along with the MP23ABS1 analog bottom port microphone, which has the capability of sensing into the ultrasonic frequencies to aid in predictive maintenance type applications. I mentioned it's powered by the STM32L4R9 variant, one of our most powerful devices. And we also have the Blue Energy M2SX family of BLE5 modules. Rounding out the hardware is the STBCO2 battery management IC for the lithium-ion battery that you saw. Just to highlight the Bluetooth modules a little bit, there are really two options: the ultra low power or low cost variations. Both of them are based on the Bluetooth 5 IC, the Blue Energy 2, running a Cortex M0 at 24 with 256K of flash and 24K of RAM. Both of these are Bluetooth 6 certified and have all the regulatory certifications for quick time to market for mass market customers. Both come with an extensive peripheral set, the I2C, SPI, UART, DMA, PDM inputs for our digital microphones, just to name a few. What differentiates the two? The M2SA comes with a high efficiency chip antenna and is power consumption optimized with an internal switch mode power supply, while the M2SP is a cost optimized PC board with PC board trace antenna and an internal LDO oscillator instead. When you use the STBLE sensor app for either Android or iOS, this allows the engineer to utilize the SensorTile.box with various levels of development. And in the case of entry mode that we're looking at here, the customer can utilize pre-programmed applications that are stored in the app itself that can be downloaded and run on the SensorTile.box. And with the data then communicated back to the smartphone or tablet via the BLE connection. Some examples include the pedometer function, simple vibration monitoring, leveling and inclination, human activity recognition, just to name a few there. The next level above that is what we call the expert working mode. This is a mode that allows the user to define the applications by selecting the desired sensors and creating functions directly from the mobile app. The expert mode allows the user to adjust the parameters of each of the sensors. For example, maybe the full scale, the output data rate, and various filtering. The customer can build this application in the working mode without writing a single line of code. That's a nice feature with this. And finally, we have what we call the Pro working mode. This mode is fully compatible with our STM32 ODE environment, targeting professional level of development. In this case, the user is able to write custom firmware based on the STM32 Cube hardware abstraction layers, middleware, and some of the various examples included. Many of the examples are available in source code level to provide a great reference when starting a new design. Next, we'll take a look at the Algo Builder application that you can run on your PC. Algo Builder is a PC-based graphical user interface and development environment, especially designed for the ease of evaluation and develop of software that you're going to embed into the microcontroller that will either manage one or multiple sensors, depending on what your desired application is. The tool allows the customer to create like a block diagram or a flow chart of the signal coming from a particular sensor's, from the inputs, the processing path that may consist of filters or embedded libraries and other functions, and then the output signals as they may be desired. This, again, done completely without the engineering having to write any code of their own. The tool is fully compatible with our STM32 IDE and visualization tools for viewing the performance of the algorithm that's generated. So this shows a graphical of kind of how it all integrates together. The Algo Builder works very well with the SensorTile.box. It's one of the best tools to fully utilize the SensorTile.box capabilities. The tool allows the customer to take precompiled code, libraries, his firmware template, and the code designed in the Algo Builder itself, combine them into a firmware project that you can use with either the STM32 Cube IDE compiler. I'll mention it's a no-cost compiler tool set for the customer. Or if the customer has IAR or Kyle, if they have a seed of one of those, they can use that also. And since the compiler, the debugger, and the programming tools are all linked into Algo Builder, there's no need for the customer to go outside of the development environment to develop, compile, and test the algorithms. Once the SensorTile.box has been programmed, the Unico GUI interface can be called from the Algo Builder to visualize the application as desired. The Algo Builder, the STM32 Cube IDE, SensorTile.box, along with the capabilities of the STBLE sensor tool for your smartphone, make for a very versatile development tool chain for ST's many different sensors.